solve this equation using the quadratic formula? Well, if we want to use the quadratic formula to solve an equation, the first thing we need to do is make sure that our polynomial is set equal to 0. In order to use the quadratic formula, your polynomial must be set equal to 0. If it's not, you need to move everything to one side of your equation in order to make it equal to 0. Now, if we look at our equation, we have our polynomial, and it is set equal to 0. So we can use the quadratic formula. In our next step, let's identify a, b, and c in our quadratic formula. These will be the numbers that we plug into the quadratic formula to solve. First, we find a. A is the coefficient in front of x squared, so a is equal to 1. B is the coefficient in front of x, so b is 12. And c is the number that sits on the end, so c is 32. Now we found a, b, and c. It's always best to write out the values for a, b, and c before you plug them into the quadratic formula. It makes it a lot easier, and you get a lot less confused plugging in the numbers into the quadratic formula if you first write out the values for a, b, and c. Now that we know what a, b, and c are, let's plug them into the quadratic formula. Remember, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, to get our answer, all we need to do is plug in the values we have for a, b, and c into the quadratic formula and solve. So first we have negative b. Well, b is equal to 12, so this is negative 12. Then we have plus or minus the square root. B squared is 12 squared. Then we have minus 4 times a, which is 1, times c, which is 32. And that's all divided by 2 times a. So 2 times 1. Now that we've plugged in a, b, and c, we need to simplify this expression. So we have negative 12 plus or minus the square root. 12 squared is 144, and if we take 4 times 1 times 32, we get 128. Then that's all divided by 2. Well, 144 minus 128 is 16. And the square root of 16 is 4. So now we have negative 12 plus or minus 4 all divided by 2. But look at what we have in our answer. We have a plus and a minus. That means we actually have two different numbers here. So in step number 5, we need to split up our answer into the two different values, the plus version of 4 and the minus version of 4. So we have negative 12, and we'll use the plus first. So we have negative 12 plus 4 over 2. Then for the other one, we have negative 12, and this time we'll use the minus version. So we have negative 12 minus 4 over 2. Now if we simplify, negative 12 plus 4 is negative 8, divided by 2 is negative 4. Here, negative 12 minus 4 is negative 16, over 2 is negative 8. So now we have our two answers. X is equal to negative 4, and x is equal to negative 8. That means if we plug either one of these values in for x into our original equation, this polynomial on the left will simplify to 0. So let's check that just to be sure. So here, we'll plug in each of these values that we got for x separately and make sure that they make a true statement in our problem. First, let's take x as negative 4. If we plug that into our equation, we have negative 4 squared plus 12 times negative 4 plus 32. Now we want to see if this polynomial is equal to 0. So if we simplify, we get 16 minus 48 plus 32. And that simplifies to 0. So that means that negative 4 is one of our answers. Now let's do the same thing for x is equal to negative 8. We plug that into our polynomial and get negative 8 squared plus 12 times negative 8 plus 32. Simplifying, we have 64 minus 96 plus 32. And that simplifies to 0. So again, we get our polynomial equal to 0 when we plug in x as negative 8. So now we found our answers. We took our original equation, found a, b, and c, then used the quadratic formula in order to simplify split our answers into the two different answers, then checked our answers, and found the answers to be x equal to -4 and -8.